So yesterday we did multiplying monomials. Today we're going to do dividing, right? I think we talked about the three properties that we did yesterday. So multiplying exponents, when you same base, you add them, and doing the power to a power, multiplying it in. Those are going to show up again today. I think there's like one more rule that we're going to cover. All right? So when you have the same factor in both the numerator and denominator of a fraction, it cancels out. What's the numerator of a fraction? What's the location? Top. Numerator is the top, and then the denominator is the bottom. We're not really going to worry too much about those terms, but we did use it here. You don't have to write this stuff down in your guided notes, guys. But we just wanted to show you that, like, 12, to get 12, we would do 3 times 4. All right? The number we would divide by would be 3, right? The two 3's, because they're the same, they cancel out. And I'm left with 4 over 5. All right? If I do this, right, to variables, all right, x to the 5th, right, what does x to the 5th mean?
X 5 times.
Yeah, x times x times x times x times x. X to the 2nd means, I don't know why you put a 2 here. Let's screw this up. All right, let's fix that. I don't know what happened there. If I have x to the 5th, x to the 5th, like we talked about, x times x times x times, why is there a 6 there? 1, 2, 3, oh, I got 5, okay. And then x to the, why? What the heck happened here? I don't need that one. There we go. All right, so x to the 5th is x times x times x. We already talked about that. X to the 2nd is x times x. I'm going to cross out the ones I have in common. They both have at least 2 x's. So like we did up here, they both had a 3. We cancel them out. They both have at least 2 x's, right? And I have 3 x's left on the top. So that means x to the what? X to the 3rd. So that's one way we could do it. We could write out whatever we have there, x to the 5th, y to the 3rd, z to the 5th, and we could write out the bottom. We could write it all out. That's going to take a lot of time. All right? That's going to take a lot of time. Let's do just so you guys can see it. Y to the 5th. How would I write that out? Yeah, y times y times y times y times y. And then on the bottom, how would I write out y to the 3rd? Yeah, y times y times y. All right. One set of y's cancels out. Another set of y's cancels out. One more set of y's cancels out. Y to the 2nd. We're going to get, Vanessa, that's cool. We're going to get to that in a second. Answer would be y to the 2nd. This one, x to the 3rd. How would I write it out? X times x times x. X to the 7th. Wow, it's a lot. 2, 3, 4, 5, 6, 7. All right? How many do we have in common? 3 of them, right? Cancel, cancel, cancel. X to the 4th, where? Top or bottom? Good, on the bottom. Now, I got nothing on the top. What can I write? Who said 1? Perfect. We're going to write a 1 there. So if we have nothing left at either spot of the fraction, we're just going to put a 1. All right? You guys want to do this next example? I got M, guys, look at Antonio. I got m to the 3rd on the top. I got m to the 3rd on the bottom. I got the same exact thing on the top and the bottom. Not 0. 1. The same rules apply. If I divide the same thing by the same thing, I'm going to get 1. Anything divided by itself is 1. I don't care if you have fractions, square roots, doesn't matter. If it's the same exact thing on the top and the bottom, it's going to be 1. All right? But like I said, we don't want to do that every time. Have to write out every single factor.
What if it's like 84 and like
Exactly. All right. So here's the rule. to divide two expressions with the same base. And you guys have this on your notes. It's right above that little list. So divide two expressions with the same base. Just like yesterday when we multiplied with the same base. Now we're dividing with the same base. When we multiply, they're on the same level, right? There's no fraction bar or division bar. We're going to subtract your exponents, so the larger minus the smaller. Right, we're not going to get into any negatives. We're not going to do that till tomorrow. Larger minus the smaller, and we're going to put our answer in the part of the fraction that had the larger exponent to start. So like x to the fifth, x to the second, all right, our answer is going to go on the top, because 5 is bigger than 3. All right, x to the fifth, x to the second. Again, I'm going to keep the base. The base is x. 5 is bigger than 2, I'll put my base on the top, then I'll just do the subtraction. 5 minus 2, bigger minus the smaller, 3. Nothing on the bottom, I'll leave it as 1. If I simplify that, it's just going to be x to the third. So that's one of the rules that that's probably as far as this stuff goes today, that's the only rule we're going to cover. But the rules we talked about yesterday for multiplication are still going to apply. So we're going to subtract your exponents, larger minus the smaller, and put your answer in the part of the fraction that had the larger exponent, just like I did there. All right? Everybody okay with this? Can I move on? No, not yet? No. You're still writing this, give me a hard time.
No.
Okay. I thought you were giving me a hard time. All right? Good? Everybody's good? Needing a good now, you sure?
Yes.
All right.
I'm not.
If you're not sure, Jordy, grab from somebody else, okay? All right, so here we go. Now, instead of writing out x times x times x times x a bunch of times, we're going to do it based on the rule we just talked about. All right? So, what's my base? X. Where? Someone tell me by raising their hand. Where is my base of x going to go? The top or the bottom? Someone raise their hand and tell me. Where's the x going to go? Liam? Nope. Think about what we just said. Where's my x going to go? In the top or the bottom? Where's my base going to go? Because I have the same base in the top and the bottom. So I can divide, but I need to know where my base is going to go. Nini says top. Why do you say top, Nini? Okay. Think about what we just said in the rule we just wrote. Where do we want to put our answer? Where do we want to put it? No? Nini, you want to try again?
Put your answer in part of the fraction that has the larger exponent.
The larger exponent, right? You said top. Now tell me why you said top.
Because it has the larger exponent.
Yeah, 8 is bigger than 5. That's why we're going to put the x on the top. So we're going to keep the base, x. We know 8's bigger than 5. All right, so we're going to put our base on the top. Now, what is our exponent going to be? Someone tell me by raising their hand. Kyle. 3. How'd you get 3, Kyle? Huh? Yeah, 8 minus. Remember, when we're dividing, yesterday when we multiplied, we had the same base, we added. Today, when we divide, we have the same base, we subtract. All right? Nothing on the bottom. What can I put? 1. I was good. I started it, right? Good. All right. What is that? X to the third over 1 is really what? X to the third. Anything over 1, yeah. Anything over 1 is itself. That's my final answer. X to the third. And you should have a spot on your thing, yep, right below that big box with the steps. We're going to get to those in a second. You have a spot to write that in. So again, today, same base, we're going to subtract. And we're going to we'll put our base where the bigger exponent was. All right? Let's take a look at the next one. I'll leave that on this case you guys don't have that. All right, I got y to the 9th over y to the 9th. Y to the 9th over y to the 9th. Equals 1. How come, Marissa? Yeah, it's the same thing. I don't care what's written there. You could have decimals, all kinds of different stuff. If what's on the top matches what's on the bottom, it's going to be 1. I don't care what you're dealing with. All right, whatever's on the top, if it matches on the bottom, It's gonna be 1. So that was a simple one. And then, guys, if you got something like, you'll see, we're gonna get into where we got some combinations, we got combinations going on. We might have, might have to multiply some exponents, so add them together, then do some division. If you had something like this, you can just cancel it out too. But for the sake of this, when it's by itself and it's isolated like that, and that's the only thing, you want to put an answer of 1. But if you got a whole bunch of stuff going on in the problem, you can just cancel it out. That's fine. All right. Just like when we cancel something out when we're doing like equations. We have a negative 3x and we want to move it and we add 3x and we cancel it out. We don't put 0. We don't write 0 there, so we're getting rid of it. Right, it's more stuff to worry about. Same thing with this. But if it's isolated like this by itself, we're just going to leave it. That's all we're going to do. Last one for this particular part. So I get z on the top and z to the 5th. Anybody want to give me a little bit of information before I try and solve this? Yeah, good. And we can write any number we want. If it's just a number, we can write it to the first power. Every number written is to the first power. We just don't write, it's assumed that it's to the first power. Just like when there's no sign written to the left of a number, we know it's positive. It's just the way it is. Just the way math works out. All right, so, Ariel, what's my base?
Bottom.
What's my base though? What is it? Z, and you said it's going to go where?
Bottom.
Why?
Because it's bigger than 1.
Say again?
Bigger number.
Yeah, 5's bigger than 1, right? Jordy, do you think you can tell me what the exponent's going to be that's going to go with that z?
5.
Careful.
What?
What are we doing now? What are we going to do? What are we going to do with the exponents?
Oh, 4.
4, why?
Oh. Subtracting.
Subtracting, right? Remember, when we're dividing exponents, we're subtracting. When we multiply, we add. When we divide, we subtract. So it's going to be z to the 4th. Nothing on top. Put a 1. I can leave it. This doesn't mean z to the 4th. It's only when the 1's on the bottom that I can simplify to whatever's on the top. This is your answer. When it's like this, z to the 4th over 1, anything over 1 is itself. That will simplify to z to the 4th. So that's like the basic stuff. Kind of like yesterday when we did this. Like x to the 2nd times x to the 3rd gave us x to the 5th. That's the basic stuff. All right? Flip it next time. Now, we're going to get some combinations. Now, this is what Mr. Hager was talking about at the beginning, before we started. You're going to need to know all the rules we covered yesterday to do this stuff today as well. The only thing we're adding is being able to divide them. Right? When we have the same base on the top and the bottom, we'll subtract. Everything else we covered yesterday still applies. All right? So, big thing, you're going to see a lot of steps here. What are there, 5 steps, guys? I don't want you to panic. Sometimes you may not have to do it. Some of the problems may not require you to do every single one. You might be only 1 or 2 of them you have to do. Very rarely are you going to get one where you have to do every single step. I just didn't want to write in every step if possible. I don't want it to write it every time. Right? It's more writing for you guys. So I'm just giving you this statement right here that you might not have to do every step every time. Like I said, very rarely you're going to do all 5 of them. Right? So this is kind of like a checklist for you. Like when we did, remember when we back to when we did elimination, we had the cases, right? We looked through and tried to see which one it was. This is kind of like this steps for you to follow to see what you can, so you can work your way through the problem. All right? So first thing, we're going to check and see. We're going to have our division line, right? We're going to check and see if we have power to a power. So that means, like we covered yesterday, when I got the exponent on the outside at the end of the parentheses, I'm going to multiply it in. You might want to add to your thing, multiply. I'm going to multiply this exponent to all the exponents inside the parentheses. That's the first thing we look for. You may not have it. You may not have that step, right, depending on what kind of a problem it is. Right? And the reminders, guys, are written for you on your notes. When we multiply exponents, right, like when we do this, Like power to a power. Remember, we're keeping the base. We're always going to keep the base.
Can I please
All right.
have everyone's attention? The varsity baseball should be dismissed at 2 o'clock for their game, which will be played at Pittsburgh State University. Again, varsity baseball should be dismissed at 2 o'clock.
All right. Remember, guys, a couple of reminders that are on your sheet. If there's no exponent written, make sure we put it to the power of 1. If you know it's to the power of 1 or to the first power, fine, don't worry about it. Remember, if we get big numbers, like we get the whole number of 3 to the second power, make sure you simplify it. Right? We get 9 because 3 to the second power means 3 times 3. So power to a power, that's the first thing we're going to look for. We may not have it, we may have it. Depends on what kind of a problem it is. Next, we're going to reduce the whole of the big numbers with exponents. So if I had something like this, like on your example here, the final bullet, when it says 3 to the second power is 9, if you have a whole number, or a big number, with an exponent, make sure you simplify it. 3 to the second, make it 9. 4 to the second, make it 16. 5 to the second, make it 25. Make sure you simplify those numbers. We can't leave whole numbers in exponent form. Right? We have to simplify them. Remember, you're taking whatever the base is and multiplying it together as many times as the exponent says. Right? 5 to the third, 5 times 5 times 5. If you're not sure, use a calculator. All right? Hit the little upside down V button on your calculator, and that will tell you as well. If you hit the number, whatever number the base is, that little button, little V button, and hit the exponent, it'll give it to you. All right? So reduce the whole numbers with exponents. You may not always have it either. Next thing, what we talked about yesterday. This is the multiplication piece. Add the exponents with the same base. Right? We're going to add the exponents with the same base. All right, we're going to add the exponents with the same base. That's what we covered yesterday. All right? Anything, remember, they have to be on, let's add this too. Let's add to it when they're on the same level. They're going to be on the same, they're either going to be in the numerator part of the fraction or the denominator part of the fraction. They have to be on the same level. Same base, same level, add the exponents. And we're still going to keep the base, like we did yesterday. So that's, this we talked about yesterday. This, number 3, we talked about yesterday. 2, you just need to know. That's probably something you guys covered in like middle school. Being able to simplify those exponents. Next thing. This is today. It's what we're covering today. We're going to subtract exponents with the same base. Put answer where the bigger exponent was. Now remember, they're going to be on different levels. In order to be able to subtract them, the same bases have to be on different levels. They're not going to be on the same level. If they're on the same level, I'm going to add them. Right? I'll multiply. So we say we're multiplying them, but we're really adding them. Keeping the base and adding them. Right? If they're on different levels, right, subtract them. Put your base where the bigger exponent was. That's what we just talked about that. This is new today. Right? Step 4 is new today. Answer your question? And then last thing, reduce the big numbers. So say if I had I'll explain it first. So check and see the big numbers that you have left, the whole numbers. First thing you want to check and see is, and it may not happen, you may not have any big numbers at all. You might just have variables. See if the smaller number can go into the bigger number. So say if we had like a 9 over 18, x to the second, y on the top. So I've done everything. I'm here now. I have a 9 and an 18. Which one's smaller? Which smaller, 9 or 18? 9, right? Can 9 go into 18 evenly? Yes. How many times? Twice. I'm going to cross 9 out. It goes in, I'm dividing by 9, so it goes in once. I'm dividing this by 9. It's 2. I would get y over 2x to the second. So that's just showing you guys that's one way to reduce, that's one way that the whole numbers might reduce. The smaller one might go into the bigger one. Another way is, let's say if I had, say I had 12 over 15 a b to the second, right? So I'm going to check and see first, can a smaller number, which one's smaller, 12 or 15? Can 12 go into 15 evenly? No. So this is, the smaller number can't go into the bigger number. But is there a number that can go into both? Number that goes into both, the same number that goes into both 12 and 15. One number, 3, right? So I use 3, I divide that by 3, I divide that by 3, I end up getting 4 over 5ab to the second. So sometimes a smaller number is not always going to be able to go into the bigger number. Sometimes you might get a situation where there's a number that goes like a number that's going to go into both. Now, if either of those situations, you don't have either of those things happening, leave it how it is. If you had like 7, if you had like 2 and a 7 on the bottom, this can't go in, 2 can't go into 7 evenly, and there's not a number that goes into either one. All right? So it doesn't work. So those are all your steps when we go through division problems. All right? With exponents. All right? All right. So make sure when you divide monomials with more than one variable that they're all lined up. You want to have the numbers over the numbers, all right? And then the same bases over the same bases. All right? Make sure they're lined up. It's going to make your life a lot easier when you're doing them. All right? Then we'll just simplify in each column. All right? We talked about this. All right? We already talked about how to reduce them. We put that in our steps already. We talked about the 2 situations to be able to do that. So let's look at example 2a. I think is that in the front of your thing or your back, on the back? 2a, it's on the front, okay. So first thing, on those steps I gave you, all right, the steps that we just wrote down, what's the first thing we're looking for? Someone tell me by raising their hand. What's the first thing we're looking for in those steps we just wrote down? Jordy, the steps we just wrote down, what's the first thing we're looking for? Power to a power. Do I have that on this example? What do I need for power to a power? What would I see? What would be in the problem? Parentheses. Are there parentheses there, Jordy? No. And like I said, you may not have any step. There's no power to a power. What was the second step that I gave you guys? Vanessa?
To reduce whole numbers with exponents.
Take a look. Do you have it? No whole numbers with exponents. Huh? This is on the 2A. I think it's on the bottom. Emily, what was the third step?
Add exponents with the same base.
And they're going to be where? On the same level, right?
Yeah.
Do I have exponents with the same base on the same level? So do I have another A on the top? I don't have another B on the top. Same thing on the bottom. I don't have that either. All right? Now I'm on step 4. Sabrina, what's step 4?
Subtract exponents with the same base.
So-
The answers were the bigger.
All right, so that in this situation, the same bases have to be on different levels. Do I have that here? Do I have the same base? Trenton, you say yes. Okay, where?
You got 15A.
All right, remember, like we just talked about here, all these things are separate. Numbers over numbers. These bases, the A's are the same base, they're lined up. B's are the same base, they're lined up. They're all separate. Whole numbers and variables are separate. Okay, keep going.
Subtract A2 and A1.
Yeah, we'll put the 1 there. What are you going to get?
1, A1.
A1, where should it go, Trenton?
Bottom. No, top.
Top. Why are we putting it on the top?
The higher.
That's where the bigger exponent was. Good. I'm going to put A. You can put A to the first, or you can just put A. Either way, on the test, it's probably going to show up like that. Probably won't have the first power. It'll just be A. If you want to write 8 on the first, that's fine too. All right, so we handled that, that's done. All right, do I have anything else that's the same base but on different levels? Antonio?
The B.
The B's, okay.
The B, the third, and the B8.
Okay, tell me what to do.
You would subtract the B third to B8.
What do I get?
You got,
Where's it go?
to the right of the A. Or on top.
Here, top or bottom? Think about the mistake Trenton just made and he corrected himself.
Oh,
Bottom, right? Why are we going to put it on the bottom? Somebody help out, Antonio. Marissa? Remember, when we subtract them, we want to put our answer where the bigger exponent was, right? Just like we talked about we did the basic ones at the beginning. If I did b to the third, b times b over b to the eighth. 1, 2, 3, 4, 5, 6, 7, 8. They all have, that cancels out, that cancels out, and that cancels out. It still leaves me with 5 b's, Antonio. That's why it's going on the bottom. I still have those leftovers. That's why the answer. That's why you put your answer, your base with the exponent, where the bigger exponent was.
So if you put it on top, it would be negative, right?
Exactly. We're not dealing with negatives. We won't get to that till tomorrow. Now, all I'm going to do right now is I'm not going to try to do 2 steps at the same time. All right. All I'm going to do now is bring the whole numbers over. Elise, what was the last step? Step 5? All right, reduce the big numbers. What was that? What was the first option we could use for reducing? Smaller number and the bigger number. Is that possible here? Elise, look at the board. Is that possible? Can the smaller number go into the bigger number evenly? Okay, what's the smaller number? Can it go into, what's the bigger number? Can it go in evenly? Can 5 go into 15?
Yeah.
Yeah, how many times? 3. I'm going to cross, the negative's still going to stay. I'm going to cross this out. I'll make that a 3. What's the 5 going to become? Yeah, it cancels out. We can put 1 or we can just cancel it out. All right? So my final answer, Derek, what's my final answer? Yeah. So this canceled out. I still got that 3 on top. What's my final answer going to be? Yeah, 3A. I agree. Oh, negative. Thank you, Marissa. Good catch. That's it. I'm done. So you see what I'm saying, guys? You're not. I think what do we use? We use 2 of the steps there. Step 4 and step 5. There was nothing else. So that's what I'm talking about. You're not always going to have every step on that list. Here's my final answer. All right? Look at the next one. Let's look at 2B. Ariel, first step?
First step, check if there's power.
Yeah?
Since
There's not. Good. How come there's no power to a power?
because it's,
There's no what?
there's no,
There's no parentheses. All right? Ashley, step 2.
Reduce both big numbers with exponents.
Yes or no? Do we have whole numbers with exponents? Big numbers? No. Then this negative 13 would have to have something here. The 26 would have to have something there. We don't have that. Josh, step 3. On the same level, on the same line. That's fine. Do we have that, Josh? No. All right. Aiden, now what? Step 4.
Subtract exponents with the same base.
Right.
Put the answer where the bigger exponent is.
Do I have that? Do I have that here? Exponents with the same base on different levels?
Yes.
Okay, what's one pair?
X.
X what?
X to the 8th.
Yeah. Okay, tell me what it is. Tell me what the answer is and where I'm putting it.
It'd be X to the 4th, and you're going to put it above 1.
Tell me why.
Because the bigger number is above 1.
Excellent, very good. Kyle, Anything else there for step 4? The y's, okay. Tell me where I'm going to put, tell me my exponent where I'm going to put it. Excellent, good. Because remember, there's a 1 here. Perfect. Now, again, I'm not going to try to do 2 steps in the same part, all right? I'm going to bring this over. Negative 13, 26. Liam, step 5. Step 5. Vanessa, step 5.
Reduce the big
All right, what's the first option for reducing?
smaller.
Can that happen here? Can this 13 go into 26? How many times? Right, so what am I going to do?
You scratch out both of them,
Scratch them all?
and 26 can be
And then this 13, we don't have to put any, we can put a 1 if we wanted to, but we don't have to. No, it's only negative on the top. All right? So Natalie, what's my final answer? All right, so I got 2y to the 4th on the bottom. Can you say the top again? X to the power of 4. Don't forget the negative, right? It's going to be negative x to the 4th. So you do all that work. You want to make sure you bring that negative over. All right? So here is my final answer. Again, that one, what were the only steps we used in that one? Somebody tell me, raise the hand. What are the only 2 steps we used? Step 4 and 5. Just like example 2a. We only used step 4 and 5. All right?
It's kind of more the same.
Yeah, that's fine, Mr. Hager. All right, now,
Is that?
that would be a little bit different, Mr. Hager, as far as the reducing goes. All right? So, guys, this one, I can tell you right now,
We're skipping 2C.
yeah, 2C was skipping, so I think we're on the back side of the notes now, guys. We're on 3A. Okay, we're looking at 4 more examples, guys. The rest, you guys are gonna do some on your own today. All right? So, and for this one, I want you to tell me, instead of me going through step 1, step 2, I don't want to do that. Can somebody tell me? I gotta know what I'm saying. I think I might have just come to that one copy. Oh, what happened? Sorry. All right. So for this one, right? Can someone tell me by raising their hand what step on our list we're going to start on? You want to tell me what step we're going to start on? Kyle? Okay, which one is that on your list? Step 4, right? There's no power to a power. There's no numbers with exponents, right? There's no, I forget what step 3 was. Oh, no, same base on the same level. So I'm step 4, all right? Give me one base somebody give me one base that's the same on the top and the bottom. Antonio? Huh? Huh? Oh, I would go step by step. If you want to do Z's first, that's fine.
Get them out of the way. I don't like Z's.
And like Z's, all right, man. Sometimes you like to catch some Z's.
Yeah.
All right, so tell me the answer and tell me where I'm going to put it.
Z4.
Yep.
And on the bottom.
Perfect. Good job, Antonio. Z4 on the bottom. If you want to cross it out, you can. Now you already took care of it. What else? Derek, what else?
Z.
So we had Z5 and Z. Antonio said Z4 on the bottom. 5 minus 1 is Z4. We put it on the bottom because that's where the bigger exponent was.
So y power 2
Where?
on the top.
Awesome, right? Because 4 is bigger than 2. Good job. Y2. All right, last one. Who said X? All right, what happens, Ashley? I got X3 and X3. It's the same thing, right? What did and you guys, you're going to think back to the beginning of the lesson now. When I said we had something like this and they were the same thing, we had a whole bunch of stuff, we can change it to a 1 or just do what?
Get rid of it.
Just cross it out.
Just get rid of it.
'Cause then what's going to happen, Ashley, we could put a 1 here and a 1 here, but when we multiply it, it's going to come out to be the same thing. So if we have something like that, we can just cross it out. Good. No other bases, right? In terms of exponents? Nothing else, right? All right. Last step. What are we going to do? Simplify the numbers. All I'm going to do is bring them over. I'm not trying to do too much in any one step. What's the first way I can check and see if I can reduce them? It's the first way we talked about, Sabrina, to be able to reduce them. If you're not sure, look at your notes. Look at step 5. Look at the first little double arrow.
Smaller number into big number.
So what is that asking then? If what can go into what?
18 going to 23.
Can that happen? Evenly? No. All right. Trenton, what's our other option for reducing? We could check and see if the bigger was in the smaller, but Sabrina said no.
A number that can go into both numbers.
Is there a number that can go into both of those, 18 and 27? You say yes, Kyle? Not sure. Okay, I heard an ant. I don't know what that meant. What do we think? Yes or no? Number that can go into both 18 and 27. Josh, give me a look. Josh, what is it then? 3, right? 3 I can divide both by 3. 18 divided by 3 is what? 6. 27 divided by 3? We even got a bigger, we can even do a bigger number here. I lied. 9. 9 will go into both, I'm sorry. I mean, you couldn't, Josh, you're not wrong with 3. You just have to, you get it to a smaller number and have to reduce it again. So this way, if you did it by 3, this would be 6, this would be 9. And then 3 would go into both and you reduce it again. But for this, I like to do it once. You're not wrong with what you said, it's just one more step. All right? So 18 divided by 9, 2, and the bottom I'm going to get, what else am I writing? Bottom, there we go. So the ones we did before this, guys, a couple we did before this, the only thing that was different was the way we reduced. All right? In 2A and 2B, we reduced because the bigger was in the smaller. This one, we had to pick a number that went in the both. So the only thing that was different was, it was still step 4 and 5, but step 5 was different based on the way we reduced. That's the only thing that was different. All right? This one. All right, let's go through it quick. I'm not going to go, I think you guys understand it a step-by-step thing. I'm not going to go through that again. All right? Somebody tell me the first thing I'm going to write and where I'm going to write it. Ashley?
The 2 on the top. I want to do the B's first.
So B2, where are you going to put that again, Ashley? I got 3 and I got 5. Bottom, right? You want to put your answer where the bigger exponent was, right? So B2 on the bottom. I agree with your subtraction. Just make sure you put your answer where the bigger exponent was. Okay, so that takes care of the B's. Someone else want to give me something? Antonio?
It's rid of the C's.
Okay.
C3.
Where?
Bottom.
Good. That takes care of that. All right. Dini? Okay.
No.
Yeah, you're right.
Yeah, but like you could just cross them out.
No.
No. Yeah. Yeah.
What's 2 minus 1?
1.
Okay. Where's it going to go? Top or bottom?
Top.
Top, right? Nini, I'm just going to put A, right? I can put A to the first, but A is okay. All right, good. All I'm going to bring the whole numbers over. What can happen now? What can happen now? Yeah, does 4 go into 6? No. Actually, this said, I can put 2 into both. Divide by 2, divide by 2. On the top, what am I going to get? 2 what? A. On the bottom, -3, B to the second, C to the third. Again, the only thing that was different with these ones, guys, was the way you reduced. It was still step 4 and 5. The only thing that was different was the way you reduced.
Are they all gonna be 4 and 5?
No.
6 and 5?
Because look at,
Oh. Can you go back? Can you go back?
All right, we're good? All right. So now, the last 2 problems we're going to do, eventually they're going to end up looking like this. But you're going to have to do a step first before they look like this, okay, using a rule from yesterday.
Mr. They have all the steps written down. Like, hey guys, this one, we're going to cover 4 out of the 5 steps on this one.
Okay, what do I need to do first? Antonio?
Those sheets and multiply everything in parentheses by 2.
Okay, and what should I put so I know what to multiply?
3, a 1,
Put a 1
and a y 1.
and put a 1 on the y. Now we're going to do exactly what you said. When I do that, is anything going to change in the bottom? No, that's going to stay exactly the same. So the bottom already looks like the problems you've been doing. It's just the top that didn't. Okay, so I'm going to have a 3 in the top. To what power? 3 to the 2. I'm going to have an x to the what power? 10th. And I'm going to have a y to what power? 2. Now, this is almost like examples 3. Almost. There's one more thing I have to do in the top to simplify it, and then I can start doing what you guys did in example 3.
Oh, the 2 doesn't
So what can I simplify in the top? Okay? Yeah, 3 to the second power. That's a number. What is 3 to the second power? Careful, not 3 times 2. 3 times 3. 9. And now I'm going to copy everything else. Okay, keep it exactly the same. Now from here, this is just like example 3. Okay. Am I going to have x's in my final answer? Yes. I'm going to have an x to what power? X to the 6th. Where is the x to the 6th going to go? Top or bottom? Top. Am I going to have y's in my final answer? Yes. Y to what power? Y to the first power. Top or bottom? Bottom. Do I need to put the 1? No, I don't need to put it. Okay. And then I still have the 9 and the 6. Those are just hanging out in front. And now, last step. What can you divide 9 and 6 by? 3. Divide by... Actually, I'll do it the other way. We're going to divide by 3. Divide by 3. What's 9 divided by 3? 3. What's 6 divided by 3? 2. And just copy everything else. That kind of problem is about as hard as it gets. That is as hard as it gets for what we do today.
Yeah.
That's it. Okay, so we have is there one question left?
Yeah.
And then the rest, to try now, we'll do that after. Okay, so one question left, and then we're all done. Any questions on that one? Okay, last one. And actually, it's very, very similar to the one we just did. Almost identical in terms of the steps that you're going to do. Okay, so somebody different than last time. Tell me what the first thing I have to do is. Shannon?
You have to do power to a power.
Okay, and I don't have some powers, so what should I fill in for them? We're going to fill in a 1 and a 1. Okay, so now Shannon told us what to do, power to a power. Can somebody else tell me what's going to be in the top when I do all those powers out? 5 to the third, yep. I'm going to have x to the sixth and y to the third. Do I have to do a power to a power in the bottom? No, you just keep it the same. 15xy to the fourth. All right. In the top, something there I need to do out before I can go any further.
You can simplify 5 to the third power.
Yeah, if we need our calculator, we can just do that. 5 times 5 times 5, 125. Okay, so even though it's a little bigger, we need to do it out because we have a number in the bottom. And we have to reduce it after. So 125. Am I changing anything else at this step? No. X to the sixth, y cubed. In the bottom, put 15x, y to the fourth. Okay. What should I deal with next? I have 3 things I need to deal with, 3 columns. Let's deal with the x's. What's going to be my x in the final answer? X what? X to the fifth? In the top. Good, I like it. What about my y's? Y, they're going to be in the bottom in what power?
1.
Yep, y to the first. Now what? Bring over the numbers. Yep, we already did the x's. Okay, does anybody see a number you can divide 125 and 15 by? 5. So it's going to put divide by 5. Divide by 5. Does anybody know what 125 divided by 5 is? What is it? It is 25. If you're not sure, just use your calculator. What about 15 divided by 5? 3. What else? X to the fifth, y to the first. You know you're done because 25 and 3, you can't reduce them anymore. What would happen if 3 went into 25? What would that mean? Like, if you could reduce this more, what would that mean? So it's kind of like what Mr. Royce had started to do and he erased it. If you can reduce it more at the end, that means you didn't divide by the biggest number you could have. All right? So always reduce it as much as you can. Hey, any questions on that rule? So what do you notice about all our exponents so far? They've all been what kind of numbers?
The numbers for the exponents, guys.
The exponents. They've all been positive. Have we ever had a 0 exponent? I don't think we've done too much with 0. We also haven't done anything with, what other kind of numbers?
Negative.
Negatives. Okay, we're not going to do anything with decimals and fractions. We don't do that in Algebra 1. But negatives, we haven't looked at yet. Okay, so tomorrow, all these rules that you know, every single rule we've done works exactly the same with negatives.
We're going to add 2 more things.
Yeah. So most of these rules are going to be the same. Okay, a couple quick reminders. Homework tonight will be worksheet 6-1 part 2. Second part of the test will be on Friday. Okay, I will let you know what you got on the first part of the test right now.
Just saying, you tell them what you decided to do with that.
I will,
Okay.
yes. This is technically going to be our 3rd test because I counted what you did Monday as a test, and I'm going to count what you do on Friday. So it's like we had 2 tests this
2
week.
separate tests.
Okay, we don't have that many grades, so that's a good way to get 2 grades in. So we had two tests this week. Progress reports closed on Friday. And don't forget, you have the double shock week. The test this week is going to be short. It's about 10 questions on Friday.
Yeah.
You already did the first 4. Okay?
Hey guys, don't put your notes away, so you have space on it. We got a couple practice problems we want you to do.